Ian and Dave with Fake It Before You Make It, mocking your way to better HTTP APIs.
Thank you. Right, I'm Dave and Ian's there. He'll be showing you some stuff in a little bit. But first, I'm going to talk about how you can use some modern tools and concepts and processes to make better APIs. And then Ian's going to give you an actual demo. So the slides, example code that we're going to show, and then links to some more information and links to the feedback page for this talk are all at this URL. I'll have it up again at the end, so you don't have to worry about copying it down right now. So first, I want to go over some terminology to make sure we're all on the same page. REST is a really big concept. I'm not going to do it justice here. I mean, there's like whole conferences on REST, let alone single talks. So, but for our purposes, we need to know it's not a standard. It's an architectural style. So it takes an API and then applies constraints to it. And these are things like it has to be client server, it has to be stateless, it has to be layered system and other things. And if it has all of those, then it's a RESTful API, truly. Most HTTP APIs aren't fully RESTful, but people use the term REST as kind of shorthand to say not SOAP. But just know that REST is a lot more than just an HTTP API that's not SOAP. Okay, so there's the concept of an API contract, and this is an agreement between the service provider and the clients. And this covers things like the technical details, like how requests and responses work. And it also covers things like the service level agreement and limits and pricing and things like that. So all of those things are wrapped up in this idea of an API contract. JSON, I'm pretty sure most people are familiar with it, but just in case you're not, it's JavaScript object notation. It's a way to serialize object data, and it is supported now by most languages, and so it should look pretty familiar. And then there's JSON schema. JSON schema is a standard for describing your data model, and itself is written in JSON. And so this can be used for validation and testing, and this is used by some of the tools that we're going to show. And then there's YAML, which is another serialization format. It's meant to be more human readable than JSON, and it kind of achieves that. And it's actually a subset of JSON, and so anything that is expressed in YAML can be converted to JSON. And it has really broad language support, and it's getting really popular. And it's used by some of the tools we're going to show too. So the idea for this talk came about a couple years ago when Ian and I worked together on an API team, and we had an internal client that needed a new feature. And it was a pretty simple requirement. They wanted us to accept a post for new data, just to create a new record. And they wanted us to return OK if we created the new record, or give back validation errors if there was something wrong. And so we did that. We implemented a new endpoint that accepted a post and returned OK or validation errors. So we committed the code, got it into our integration environment, and then they said that's not what they wanted. So we weren't really thrilled because we gave them exactly what they asked for, we thought. So the difference was really subtle. And now this is simplified, but this is kind of the idea of the difference between what we did and what they wanted. So we provided them with basically a status saying like it's not valid, and a dictionary of the keys that had problems, and then a description of the problems for each key. They were expecting a list of these dictionary items. And the reason they were expecting this is because they worked with 2 or 3 other APIs that gave them responses this way. But we had no idea to anticipate that. So we gave them not exactly what they wanted. And so we thought we could do better than this. We realized we could change our process so that we wouldn't have these misunderstandings. But what we didn't want to do is let the client just dictate what the requests and responses would look like. We want to still design our API, but we wanted to be able to get early feedback from them without having to do our implementation first. And so at that time, we'd been hearing a lot about this idea of API contracts and API specifications. And that's when it really clicked that this is something that we could use in our process. So an API specification is a machine-readable description of the resources that are available via your API. So the requests and responses, it's the basis of that API contract, along with those other things that I was talking about, like SLA and limits. And so over the years, there have been a lot of ways to specify APIs. And so back in the days of SOAP, there was something called WSDL. And then as RESTful or REST-like APIs started coming on the scene, there was an attempt to do something like WSDL, and it was called WADL. But it was really verbose XML. It wasn't fun to use, and it really didn't have a lot of uptake. And it was kind of silly that we're moving to JSON APIs, but then describing them in XML. So that didn't really catch on. Luckily, there have been some newer specification standards for RESTful or HTTP APIs that are REST-like. And so there's three big ones. The one that you may have heard about, because there's kind of the most buzz, is Swagger. And it's in the process of being renamed the Open API. Open API Initiative is the organization, and Open API Specification is the language. There's one called Rammell, RESTful API Modeling Language, and there's one called API Blueprint. So we're going to take a quick look at all three of these and kind of see how they work. So Swagger, like I said, it's in the process of being rebranded Open API. But if you Google for it, you're going to find a lot more with the name Swagger. So it's a JSON specification. So the actual spec is written in JSON. It has a very rich ecosystem. So there's support for just about every popular language and framework. So that's a big plus. Swagger version 2.0, which came out less than a year ago, a few months ago at least though, now you can author the spec in YAML and the tooling will convert it to JSON, and then the other tooling will use the JSON. So it's a little easier to author if you're doing it by hand or in an editor now. And like I said, there's this Open API specification, and the umbrella organization is called the Open API Initiative. And it has a lot of the big players in the tech world, a lot of the names you know, behind it. So I think this is, it's definitely kind of taking off. So here's an example of a really simple Swagger specification. And like I said, the complete examples are all on that site, so you can take a look at them later if you want to. But we see at the top, we basically say what version of Swagger we're using, and then we describe some really basic information about the API, like what the API does, the version, some contact information, things like that. And then we get into things like the schemes that it supports, so HTTP or HTTPS, and then what it consumes and produces, so like JSON or XML, or sometimes even YAML. And then as you work down the specification file, you describe the endpoint paths for your API and the types of requests that it accepts and the types of responses that it expects to respond with. And then at the end of the file, you can define common definitions that can be referenced throughout the specification, so you don't have to repeat yourself if there's a common object model that you're using. So we're going to take a quick look at Rammell. Rammell is authored in YAML, so there's no JSON in between. Rammell was designed with the mindset of modeling your API, where Swagger came about. The initial purpose was to describe an existing API, so you could tell others about an API that exists. Rammell was created with the intention of using it to design your API first. So they kind of came at it in different directions. Rammell supports a lot better inheritance, so you don't repeat yourself as much, and it does things like not only describing common objects, but you can import other Rammell files. So you can build up an API from multiple spec files into one. Version 1.0 was just released, so most of the tooling that you see is for version 0.8, and the example I'm going to show is version 0.8. It looks like the main projects are adding 1.0 support, so that should come online soon. So it kind of solved some of the pain points of the earlier versions, but the support's not quite there yet. And the spec itself was created by a company called MuleSoft, and they are by far the largest supporter of it, but there is an independent work group that actually maintains the spec. So they do take outside contributions. So we're going to look at the Rammell example. And again, this is authored in YAML, and it starts off pretty similar where you define the version that you're using of the spec and some basics about the API. And then you get into defining those common object models using JSON schema. So this is where it gets a little different. So we can be more specific in Rammell about the objects that we expect our API to ship back and forth. And then we do the same thing that we were doing in the Swagger, where we define the endpoints and the requests and responses we expect. Excuse me. And now let's take a look at API Blueprint. So it takes a little bit of a different approach. So it comes at it from the idea of documentation as a specification. So this is authored in Markdown with a few extensions to support specifying the data. Most of the support for Blueprint is in the Node and .NET world. So there's a little less Python if you're doing Python-specific things. And API Blueprint is supported by a company called Apiary, and it's really built into a lot of their tooling. But like Rammell, they do have an open RFC process, and they do accept outside contributions. So with Blueprint, we see it's a little different, where we describe some kind of metadata at the top, and then your level 1 headers have specific formats that describe the API, and then the top level endpoints, and then the level 2 headers define the objects, and then underneath those are the requests and responses. So, and it kind of continues along the same way, where you define all the requests, responses, and data types that are going back and forth. So all three of these specs, they're a little different, but they can all be used for most of the same things. So the big differences are the user base. Swagger's is by far the biggest, and so Swagger also has the largest set of tooling, but I'd say that the tooling that does exist for the others, for the specific languages and frameworks, is just as good. So if there's, for instance, Rammell has a really good support for Flask. So if you're using Flask, the difference between Swagger and Rammell support isn't the big deal. So the decision point is more the language itself. So it depends a lot on what language you're using. So which one you use is really going to depend on whether the language or framework you're using is supported, and whether you're planning on sharing the specification file itself with other people. In that case, Swagger is the most popular, so that's what other organizations would understand most likely. But so it really depends. And so I'd recommend, if you're going to be doing this, take a quick look at all three of them and do a really basic endpoint to kind of get a feel for how it's going to work with your setup. Okay. Do we have a question? So the question was, are there any tools to convert between them? And there is, and I actually have a link to that on the example website. And so it does a pretty good job. It misses some data, it leaves some blanks with things that aren't covered by the other specs. But so it actually makes it really easy. When we were trialing this internally, we built up the spec in one language and converted it, and then completed it in all the languages to see how they compared. So how do we go about creating the specification? So there's two different ways you can go about this. If you already have an API, There's going to be language or framework-specific tools to introspect the code and develop the specification for you. There's a couple proxy tools that will actually read the requests and responses and develop the spec for you. But then if you're starting from scratch, there are editors that allow you to build up the spec. And so all three of them have online visual editors that are hosted. And then Rammell has one you can download, and they also have an Atom plugin that allows you to build it. And then Swagger has a couple downloadable editors as well. So once we have a specification, what can we actually do with it beyond describing our API? So the big thing or the big win that you get from having this is being able to generate documentation. You can generate just flat HTML, or all three of them have a little more interactive single-page applications that you can create that show you how to interact with the API. And they can all render to PDF really easily. And then what Ian's going to show you an example of is mocking. And so what you can do is you build up a new feature in the spec, and then you can provide a mock server URL to someone that's going to be integrating with it, and they can actually see how interacting with the API would work. And so that's, I think, a really powerful feature that is undermentioned. We can use it for testing. So you can generate tests to verify that what you implemented actually matches the spec. So this is something, if you have like a QA function in your organization, you can give them the spec and they can use that as part of their acceptance testing. And then there's Cogeneration for most of the popular frameworks for most of these specification languages. So you make your change and then you run the Cogeneration, and it will build a stub for the new feature that you added. So with using these tools, we can work from a contract-first mentality where we define that API contract, and then we go ahead and do the implementation afterward. So now, Ian is going to show you how you actually do this.
Hi, everyone. I hope the AV works and everyone can hear me. So basically, as Dave said, he introduced why we are building our specs and the different approaches. I'm going to go ahead and talk about an example for how basically you're going to use this in maybe a real-world API that you're using. And just to go through the example first, like what we're going to do. So you would basically start from the fake it. You have the spec that you have built. And you either have a new spec that you are writing, or you're updating an existing spec with an endpoint. Then you publish it, and as Dave mentioned, you build either a single-page HTML, or maybe you want to do it with a PDF. And after that, the really powerful feature is that you can mock it, because this is structured data. It's very easy for the computer to read it and for you to build something that will be able for your clients to work against and work against your mock. Then the other part, obviously, you have to then make it, and then you have your API. You are doing an implementation, which I'll show with the basic Flask app. And then the other really powerful feature for me is the fact that you can go ahead and validate that your spec is really defines the API, and you don't have a drift between the spec and the API, which was a big problem when we working together in our organization, I'm sure in other also. So now we'll go into the demo, and I hope the AV works again. Yep, OK. So we'll start with a simple example, and since we're in Ohio in a conference, let's imagine we're working for another conference company. We're called Best Conferences, and right now we have an API. We have a website where we submit talks, the same as David May submitted it. And what we want to do now is, what we want to do now is basically to create a REST API for submitting the talks and getting information from them. So We don't want to do too complex of an example, just a basic example to showcase those features. Yep. I don't know why that switched, but okay. Yeah, real-time examples. So we start with our best conferences example, and the first thing, as we said, we want to build our spec. So let's imagine that we did a comparison that Dave was talking about. We decided, we thought about Swagger, we compared it to Rammell, and let's just say we decided to go with the Rammell because that's my preference, and that's also better, as said, when we're building a new API. This example is going to use the Rammell 0.0, and the main reason for that is because as the tooling, the 1.0 has been released only, I think, earlier this year. The tools are still not up to date. I know there is active development on the tools that I'm using to get them to the 1.0 version. But right now, we're using the 0.8. We have our API. The base URI is restbestconferences.com. And we have two endpoints. The first endpoint is /talk, where our clients, our users, are submitting the talks, and they're doing a basic post. And the body is described using a JSON schema that's very easy to read. And the properties are title, speaker, and abstract, as you would have for a talk. All of them are required. And we have here the response will be 200, where we're getting back the talk ID, basically. And that's what you would expect. And as Dave mentioned, it's very easy to, with Rammell, to have includes and have all the other common responses like 500, the 404, to have them being basically applied to all of the endpoints. So this is how we approach that. And then our second endpoint is the /talk ID, because you see this is indented. And this is a basic get that we can get information about our talk. So we built this Rammell, and it looks very nice. But this is not something that we want to do. We want to give to our clients to basically work with. What we would prefer to do is publish it as an HTML for now. And there's a tool, Rammell to HTML, which is a very nice Node.js application, where we're passing it the best conferences Rammell, and we are generating the best conferences HTML. Yeah, I keep doing that. So we are generating our HTML, and after that we can host it on the server or whatever you want. Right now I have it just on localhost. Yeah. Yep. So this is basically the HTML we generated. And you can see your clients can go in. They can examine the endpoints. They can go to /talk. This supports the post. They can press on this. They can see the example of the request that they're supposed to send and the responses that they're going to get. The nice thing is that specifically for this tool, and as we mentioned, there are other tools, of course. This is more about the process. But this one accepts also you can give your own HTML non-JAX template. So it doesn't necessarily have to look like this. You can do your own color scheme and basically to look the way you would like. You can also add additional documentation to be rendered together into your Rammell, so that, for example, if you want to describe how to do authentication for your API and things like that, you can add this in here as static pages. So now, once the client saw that HTML, they obviously they would like to have something to a mock server or something to run against. They would like maybe to build their own small Python implementation requests where they can send requests and they get some responses. And that's the main big feature that Dave was talking about, where we can actually run our Rammell mockup server against this implementation that we have built. And this is also a Node.js tool that's basically reading our Rammell. It basically, through the introspection, it read that it has two endpoints, talk and talk ID. And this is basically now listening for requests. You can run it in your environment and give the client's ability to go against it. So now, if I go against our mock server, I'm getting the response that generated with all the information. And this is how the client can code and get the ability to understand what they're going to get with their implementation. And it's as you would imagine, this is just random generated stuff that they would get. At this point, you published it to the clients, and they read the HTML, they saw the mockup server, but they might decide, well, this is actually not what we have agreed on. They were actually, from their discussion, expecting another. They think that once they do GET requests, they're actually expecting to get a review string also being sent. So we can easily go here and edit our Rammell. Hopefully this will work without me messing up some syntax. Basically, nope. So we'll add here another property with review. And we'll make it another type string. And obviously, there are different types that are supported by the JSON schema, but just to keep it simple, yep. Thank you. And we would add this also to the required and have here review. We'll regenerate our HTML, and we'll also have the mockup server up there again. So hopefully, once we refresh this, and we would go here to talk ID, we would see that the response actually has a review, so the clients are actually seeing now. And usually at this point, you would have your application built, and you would need to go for another development cycle and update and do some more tests against it, all of that stuff. Versus here, all you had to do was update your Rammell file, which was very easy for you to do, and right away, with a matter of minutes, maybe an hour, get it up to the clients to see this is our updated API now. The same thing with the mock. Now when the clients are testing their implementation, they are getting this extra review parameter and getting the expected API right away. So they don't need to change their implementation. They didn't need to go against the wrong one again, stuff like that. So now the only part that's left, we agreed with the clients, this is what they're expecting. Now we can go ahead and build it. Just to save some time, I built a small Flask implementation that basically has those two endpoints. And we have it running right here. So I'll just do a small test that's running and generating a request against our implementation of the Flask app, and we submitted a new request. It was given request ID, and we got back the talk details are like this. We can run it again and have a talk ID 4, and again, regenerating it, and basically it's submitting it against our Flask application here. So this is not super exciting. It was more just an experiment with Flask. But the reason I want to show this is specifically because to close the loop on our last on our last point, which is the validation part. So this is a basic script that I wrote because I couldn't find any tool similar in Flask right now. I think there are similar tools in other languages, but basically it's using a package that was written by Lynn Root at Spotify, ramifications. And ramification gives you the ability to basically read your Rammell and get an object representation of it. So down here, I have two basic dictionaries. The spec resources, which is basically the Rammell representation of our resources using a dictionary. And the implemented, which is basically I'm doing an introspection of the Flask code, and I'm getting all the implemented endpoints. After that, our script does a basic for loop, and it checks that all the resources that were defined in the spec are also implemented in our app. So this way, you can always make sure you can set up your Jenkins job or something similar, and make sure that your spec is up to the date to the implementation, and we don't actually have a drift of it. So we validated, and we see that the implementation is basically up to spec. Now, once we add another endpoint, and we run it again, we would see that there is an endpoint missing, basically. And you can obviously go much farther with this. You can do an introspection and make sure that the endpoint supports the methods that you would expect, since in your Rammell you are specifying the post and the gets. And also you can build in which parameters you're looking for and things like that. I think that's pretty much for the demo, and I think Dave would go in a little bit more into a few more tools and some summary of this. Thank you. Sorry. Yep. Yeah.
We're good? We're good. No? Can you hear me now? Awesome. Okay. Yeah, so just to wrap up, I wanted to point out some Python specific support for these things. So for API Blueprint, there is a parser called Blueprint. And for Swagger or OpenAPI, there are a ton of parsers that have been implemented in Python, and a few of them seem to be just about as popular as each other, so you're going to have to take a look at each of them. But also for Swagger, there's a pretty neat thing called Connection. And what this does is you use this with your Flask app, and it takes over the routing for your Flask app. And so all of the routing is configured via your Swagger specification. So your Swagger spec maps the HTTP endpoints to your Flask functions. And then for Rammell, as Ian mentioned, there's Rammelfications, which gives you that object model. There's a new project called Griffin, which gives you Python-specific documentation for your Rammell. And there's a project called Ramses, which is this like full framework for doing a RESTful API based on data that you have either in Elasticsearch or Postgres or Mongo. So those are all out there, and so there is good Python support for these ideas. And so the links to those resources and some more further reading is going to be at that URL. So thank you. A few minutes for questions if anybody has questions. Or not. It's cool. Okay, thanks. Oh, yeah. Yeah.
No, I didn't. So the
question was, did we use Rammell to generate the unit tests? Yeah. And I think Ian actually did this. So.
I think this works, right? Yeah. So no, you could go that route. I didn't do it specifically here or in our example because I think when you have a real REST API, you would need a lot of specific domain data that you would need to generate, and then another data that you would get. Another thing to consider is the fact that when you're doing it, you would put well, I guess that's a little bit different from what you're asking. I was thinking more about like testing against with the Rammell. But yeah, you could probably generate a unit test or end-to-end test out of your Rammell. But it might be that you would have a problem how to exactly generate the data. Because you might not be able to really specify all of your conditions in your Rammell. That might be yeah. Not generating, it's just the mock server that gives you random data based on the conditions in the Rammell, based on how you specify the properties.
Okay, so if you're working on an existing API and you modify your Rammell specification, you would regenerate the HTML piece.
Right.
But there's really nothing else. The rest of it is
no, the mock server, so I stopped it here just because I was in the session. But generally, the mock server should pick up the changes to the Rammell file on the fly. Yeah, that is not a problem. Cool.
Thank you.
Thank you, guys.